All right, thanks for tuning in. Today we're going to talk briefly about domain, and in particular we're going to look at it for two types of functions, because right now you all are able to handle this graphically really well. If you have a chance to plug it into Desmos, you guys are rocking 100%. When it comes time to find something algebraically, we're struggling a little bit more. So we're going to take a moment and talk about what domain means. We already know that domain means the set of all possible inputs. It's what you can plug in. And so in particular, we're going to look at two types of functions that we know there are certain values that you can't plug in. For us, this looks like this type of parent function, a rational function. It has a denominator with a variable in it, and this type of function, a root function. And in particular, an even root function, one with like a square root, a fourth root, a sixth root, something like that. Each one of these has limitations based on what you can't plug in. We know that if there's a variable in the denominator, the one thing that that variable cannot be, it cannot be 0. Which means that for the parent function, 1 over x, the domain is anything as long as x does not equal 0. Because if x equals 0, we're dividing by 0, which is undefined. So for this function, what we'll say is that the domain includes all real numbers that are with a bar through it, where x does not equal 0. And that just means all real numbers as long as x is not 0. For this more complicated function, we're still looking at the same thing. We focused on the denominator here, and the same will be true here. The only thing we need to pay attention to is where the denominator will be 0, because that's where the function will cease to exist. So this function will work everywhere, except we need to make sure that we find a place where this denominator does not equal 0. Because that's the one place where this would cease to exist. And so we solve this just like we would solve any other equation, except instead of finding what x is, we're finding what x isn't. First thing I'll do is I'll add 9 to both sides. That means 4x cannot equal 9. Then I'll divide both sides by 4, which means that x cannot equal 9 fourths. And so we write that answer the same way we did over here. We say that the domain is all real numbers, r with a bar through it, where x does not equal 9 fourths. For even root functions, we know that the function will be undefined whenever the inside of that even root is a negative number, because that would result in imaginary numbers. So, in this situation, we know that for h of x to exist, the input, x, must be greater than or equal to 0. 0 is fine, square root of 0 is 0, so that's defined. But anything less, square root of negative 1, is not defined in the set of real numbers. And so, we would say that the domain is all real numbers where x is greater than 0. Same process again. We focus on the part of it that makes it undefined. So even though there's a negative 7 out front, the only thing that matters to me is the inside of this root, which means that 8 minus 2x must be greater than or equal to 0. If this is a negative number, then that whole function ceases to exist. And so I'll solve this just like I would solve an inequality back in 7th or 8th grade when we were working on inequalities there. I can subtract 8 from both sides, so I'll get negative 2x is greater than or equal to negative 8. And then from here, I'll want to divide both sides by negative 2. This is actually where 90% of folks lose credit on this sort of a problem, because if you divide by a negative number or multiply by a negative number, an inequality has to flip. If negative x was greater than something, then positive x has to be less than that something. It's a little bit funky. Ask me about it if you're frustrated. That means that x must be greater than or equal to negative divided by negative is going to be a positive 4. So x has to be less than or equal to 4. That actually makes a lot of sense, because if I plug something in greater than this, like if I plugged in 5, well, that would be negative 7 times the square root of 8 minus 2 times 5, negative 7 times the square root of 8 minus 10. 8 minus 10, I'm going to end up with negative 7 times the square root of negative 2. And this does not exist within the subset of real numbers. There is no real answer to the square root of negative 2. And so, we would say that for this function, the domain includes all real numbers where x is less than or equal to 4. So the process is really simple. For a fraction like this, find where the denominator is equal to 0 and exclude that point from the domain. For a radical, find where the inside of the radical would be greater than or equal to 0. Solve for that and you'll have the domain. This is a little complicated. Watch it twice. If you're still frustrated or confused, flag me down. I'm happy to help.